Hi, we're back with another puzzle.
I'm FullDeck,
And I'm still missing a few cards.
as always. We're back today for a guest solve on with BremSter puzzles, and the puzzle we're going to look at today is Hawking Radiation by Sotek. Now, when Brem sent us this puzzle, we saw the title. We remember solving one, we think, by Heliopolis, a puzzle called Hawking Radiation. And so we're actually really excited that this is one we haven't seen before. I mean, we loved that puzzle. No, that was an absolutely stunning puzzle, but we really do prefer doing blind solves when we do guest solves for Brem. So
let's read the rules.
Let's read the rules. All
Normal
right.
Sudoku rules apply. Every row, every column, and every box must contain a complete set of the digits 1 through 9.
Okay. And in addition, we have killer cages. So digits in cages, and cages are the shapes that are outlined by dashed lines. Digits in cages sum to the number in the top left corner of the cage. So these three cells would sum to 11, since that's the number in the upper left corner. And digits may not repeat in cages. So even though under normal Sudoku rules, I could, for example, have 2, 2, and 7, since those sum to 11, because these digits are in a cage, I cannot repeat the 2. So those are the rules. That's
nice short set of rules.
Nice short set of rules. And so we will restart the puzzle to restart our timer, and let's give this a whirl. That's your line. I stole it.
That's okay.
Okay.
Okay, I have a deduction.
Already?
Yeah.
I'm still just looking at the puzzle.
I know,
Okay,
but
go for it.
The puzzle, I have a deduction.
Okay.
If we know the sum of the digits in a column, and
Uh-huh.
we do.
We do.
Yes.
Yes.
What can we say in column 2?
So should we go through the sum of the digits in a row or column?
Yeah, we like to call this combinatorics.
We do, indeed.
So,
well, you have one way of looking at it. I have another.
Yes. It was discovered by Gauss.
Yes.
When he was very young. That if you write down the digits he did the digits from 1 to 100 because his teacher asked for it. But if you write the digits from 1 through 9 down in a row, and you write them down in the opposite order underneath, and then you sum both rows, every column in the row sums to 10.
So 10, 10, 10, 10, 10, 10. We got 9 sets of 10.
So that's 90.
90.
And we divide by 2, we get...
Because we have the digits 1 through 9 twice.
Yeah.
So 90 divided by 2 is 45. So the sum of the digits in any row, column, or box is 45. In this column, we have these 3 digits summing to 9, and these 3 summing to 12. 9 and 12 is 21.
Take it away from 45.
Take it away from 45 is 24. The only way, the 3 largest digits we have available are 7, 8, and 9. 7 plus 8 plus 9 is 24. So these have to be 7, 8, and 9. Otherwise, we are out of luck and cannot hit.
Yeah. And the 8 cage
and
can't
the
have an 8
8
or a 9.
cage cannot have an 8 or a 9. So this is a 7. That's a 1.
If you do a lot of killer Sudoku, you end up learning certain things. Like if you have a sum of 3 cells adding up to 24, it's got to be 7, 8, 9. If you have 3 cells adding up to 6, it's got to be 1, 2, 4, 1, 2, 3.
Yep.
Summing to 7, it's got to be 1, 2, 4. Useful tricks that you end up learning.
Let's see if we can do the same thing in column 8. We have 15 and 21 is 36. So we're missing 9. So these 3 sum to 9. That's not quite as powerful.
No.
That would have been nice. But let's see. Oh, but 12 and 8 is 20. 20 and 15 is 35. Oh, no, this sum to 10. I was thinking we only got to 30, which would have been more powerful. Okay, but we didn't. Okay, let's see what else we get. So this 7 cage can no longer be 1, 6 because the 1's used up. It could be 2, 5 or 3, 4.
Can't be 5 in row 5 though, because we need 10 across those 2 cells you just looked at. Neither of those can be.
Oh, that's nice. Yes. So if this is a 5, 2, then it would have to be 2 there and 5 here. A 2 here, we are missing 10 for row 5. So again, 8 plus 12 is 20, plus 15 is 35. These 2 cells, I'm going to mark those in yellow, need to sum to 10. So if this 7 cage is a 2, 5, the 2 would have to go here paired with an 8. Because we couldn't put a 5 here, it would need a 5. Otherwise, we have 3, 4. If we put a 3 here, it would require a 7 there, which would break the row. So this cannot be a 3. It could be a 4 there with a 3 here. if we have a 4 here to make 6, we need to make 10, we need 6 in yellow.
So above that is either a 1 or a 3.
Okay, that's nice. Silence falls as we stare at the grid, looking at where we can go next.
So 10 and 13 in box 8 is 23. Leaving 22 in 4 cells. It's not helping.
No, at least not to me yet. But we can't have 9 in a 3-cell 10 cage, and we can't have 9 in a 3-cell 11 cage.
Or in the 9 cage.
And we can't have 9 in the 9 cage.
So it is in one of those
so
3 cells.
Yes, so one of these is a 9. And normally I wouldn't mark 3 cells that aren't in the same row column, same row or column within a box. But I think this is useful because if this is a 9, that's a 1, and otherwise we have a 4-9 pair here. So I think marking that is worthwhile. There's a lot of 3-cell 21 cages in the grid. There's one here, there's one here, and there's one there. A 3-cell 21 has to have either an 8 or a 9 or both. So we have either an 8 or a 9 in here. I'm not sure quite what to do with that. So this 9 cage in 3 cells has to have 2 of 1, 2, and 3. So the 12 cage can only have at most 1 of 1, 2, and 3.
Which rules it out having a 7, 8, or 9.
Well, we already had the 7, 8, and 9 ruled out because they're here.
Yes.
Very helpful.
Yeah.
Always on top of things there. That missing a few cards guy. So no, that is actually quite helpful. So this one is going to have 2 of 4, 5, and 6, and 1 of 1, 2, 3. And the 9 cage.
So between the 12 and the 13, we have.
Between the 12, this 12 and this 13, yes.
We have.
All 4, 5, and 6. Yeah.
So the 10 cage cannot have a 4, 5, or 6 in row 7, column 3.
Or a yes, right.
I couldn't have a 5, but so it can't be a 4, 6. Tiny deduction.
Tiny deduction, yes. Yeah, because 1 of 4, 5, and 6 is in here. The other 2 are in here. 1 of 1, 2, or 3 is in here. The other 2 are somewhere else. Wow. I am feeling very slow with this puzzle.
Yep.
The 15 cage is either 4, 5, 6, or it has a low, a middle, and a high. This is one of the tricks we've learned from Brem. Is this going to be an entropy puzzle?
I don't think so.
Okay. Same for this one. It's either 4, 5, 6, which would make this a 3, 9, or it's got a low, middle, and high, but that doesn't really do much that I see at the moment. I'm sure there's a question of where should digit X go in row, box, or
four and
column
6 in
line?
box 8 are restricted because they
4
can't
and
be in
6
the
in box
10
8.
cage. The 2-cell 10 cage crossing box is 7 and
Right.
8.
Okay. Yeah. 4, 5, and 6 are not allowed in here. Yes.
One of them can be in the 13 cage.
Yeah. One can be in here. One could be in. Well, we
Well,
could
4
have
and
both
5
4
could
and
be
5
there.
could be in there. Yeah. Maybe the question. So we know that 9 has to go in one of these two cages. 8 can't go in the 10 cage, and it can't go in the 9 cage. So, but it could go in the 11 cage as long as it's paired with a 1, 2. So, wow, I am not seeing what I'm sure I should be seeing. So the 9 cage has to have either a 1 or a 2. The 21 cage, each of these 21 cages has to have either an 8 or a 9, or both.
Has to have 2 of 7, 8, and 9.
Yeah, 2 of 7, that's a good way of thinking of it. 2 of 7, 8, and 9. So 2 of 7, 8, and 9 are here. There could be, this 21 cage could have 2 of 7, 8, could have a 7, 8, or 9 here, and the other one in here. It's 19 cage?
The 19 and the 21 between them.
Oh, the 19 cage also has to have either an 8 or a 9.
The 19 and the 21 cage between them sum to 40, which seems very
That's
high.
a lot of big, yeah. Okay, so the top 6 digits, 98765. 8 and 7 is 15. Yes, no.
45 minus the bottom digits.
Yes, thank you. No.
1, 2, and 3 add up to.
Yes, okay, thank you. Yes. So 1 through 9 add up to 45. If we remove the lowest 3, which is 1, 2, 3, we're at 39. Yes. Okay. So what does that do for us? Isn't that what I said? I thought I said 39. I'm sorry. I am this cell.
So there must be a repeated digit.
Right. And this cell sees all of those. So this cell, if it's the repeated one, has to match up with those two would have to match up if that's the repeated. This one sees, though, only those. So we gotta get a repeat there. This cell doesn't see them all. There's no cell that sees all of the other cage, so that's... Oh, but we have the same thing happening here. And this cell sees all of this 21 cage as well as the rest of the 19. So this cell can't be the one that repeats with this 21 cage. And the geometry, this is killing me. I'm not sure this video is going to see the light of day.
Oh, I'm sure this video is not going to see the light of day.
Shall we just stop now?
No.
Okay.
We'll give it a good shot.
Ooh, I feel like I have, and my brain is hurting. So, okay. Oh God, this is going to be set, isn't it? Set equivalence theory, and where do things go? And look at this. We've got like most of a fistimethyl ring happening in almost. Oh, I am in dread here. Okay.
So if we look at box 8,
Okay.
we have a 10 cage and a 13 cage, which sums to
That's
23. An 11 cage, which sums to 34.
34 less, including that one. That's 34 right there.
So if the missing cell is X,
Oh, you're gonna make me do this again? No, no, no.
you worked out so well last
Oh
time.
no, no, oh no.
Bobbins.
Oh, oh, this is not a good thing. Okay. Well,
So 33 is really low, and once we take out X, it's even lower still.
34.
34. It's still really low.
34, 44 with two wings. So these two together, I mean, these bunch of cells together are one less than the total we need for the whole box. So these two cells have to be added together. The two green cells added together are one less than the blue cell. I got it this time, right?
I think so.
Awesome. Okay. So these two cells added together are one less than this.
And that's at most 6.
It is. And these two are at least 3. So this has to be at least 4. So this is 4, 5, or 6. Right?
I think so.
If this were 4, we'd be missing 5. So these would have to be drawn from 1, 2, 3, 4. But these would have to be a 1, 2 pair. If this were a 1, 2 pair, we get an 8, 9 here, and then a sum of 8 or 9 here. I'm not sure that really helps. No, it does. If this were a 4, this couldn't be a 4, 9. So if this were a 4, we'd have 1, 9,
Yeah.
2, and then something that sums to 9. I'm not sure how much that does for us, but that's just something. I'm keeping my colors too. You can tell me to get rid of them, but I don't want to. So if this were 6, then one of these could be as much as 5. This can't be as much as 5. So this is 1, 2, 3, or 4.
Oh, they have to sum to 1 less, don't they?
Right. Right. So if this is 6, these sum to 5. So these are at most 1, 2, 3, 4. So this is 6, 7, 8, 9. This is the low digit for the 10 cage. This has to be the high digit. Okay, that was a little something. That was helpful. Now what? I mean, we know these are 1, 2, 3, 4. I don't know that that helps us either. Well, they can't be 4.
No.
And the reason they can't be 4 is if this is 4, for example, then we wouldn't be able to use another 4 in the cage. We would already be at 9. So these are not 4s. They are taken from 1, 2, 3. So 2 of 1, 2, and 3 are used up in box 5. 1, 2 with a 6, 1, 3 with a 5, or 2, 3 with a 4. I just needed to say that for myself as part of my processing. So, okay. So now.
So I don't think the 10 cage can have a 4 in it.
Which 10 cage?
The green 10 cage.
Okay.
Because if that was a 4-6 pair, we'd need a 5 in the blue, and the other one would have to add up with 4 to less than 5.
And we had already decided this couldn't be a 4-6 previously from other logic.
Oh,
so
right,
I agree
we
with you.
did,
Yes.
yes.
I had forgotten. So, but doesn't that go the other way as well? If this is a 4,
Then that
no,
could be 6.
because
That could
that
be 1, 9.
your the logic before was relying on this being a 4-6. So okay. can we do something similar with box 5? This is 15, and this is now at most 5. So this is at most 20. I mean, these are either 18, 19, or 20. I mean, these 5 together are 18, 19, or 20. Does that do anything for us? Not convinced that it does. I'm intrigued about where 2 goes in this row. Because if the 2 is not there in row 5, 2 can't be in a 2-cell 12 cage. So the 2 is either in the 7 cage or it's in the 15 cage. If it's in the 15 cage, it would have to be 2, 5, 8, because the only other possibility is 2, 4, 9, and we wouldn't be able to use a 9. So if this were 2, 5, 8, 4, 6 works, and this would be a 3, 9. Okay.
There has to be either a 4 or an 8 in the 15 cage.
Tell me why.
So I'm looking at the killer calculator.
Okay.
That means the 12 cage cannot be a 4-8 pair.
So if this is a 2 here, the 8 goes there, and then we don't have 2 or 8 or 7 or 1 available.
It'd have to be 4, 5, 6.
So it'd have to be 4, 5, 6. Okay. So
the
yeah.
5 has to be in the 15 cage. It can't be in the 12 cage.
Oh, that's the easy way to see. That's helpful. That's very helpful. Okay. So we have a 5.
We don't have a 1. So it's 2, 5, 8 or 4, 5, 6.
Okay, which matches up with what's here. But yeah,
And
but that does mean this is a 3, 9 either way.
Which resolves the 9 cage.
Which resolves... Oh, right, because this is now a 1. That's an 8. So once again, we went and did all sorts of weird other stuff that we didn't need to do.
And these indeed 4, 5, 6.
And this is 4, 5, 6. Okay, but that's helpful.
And now the 7 cage is resolved.
These can go away. Hang on. The 7 cage, which 7 cage where are we talking?
The one with the 2 in it that you just put in.
Oh, yeah, that's a 5. Excellent. Okay. And the 2 comes out here, so the 8 comes out there from our sum of 10. Okay, that is really quite helpful.
So now the 8 in box 8 either goes in the 11 cage with a 1-2 pair, or it's in the 13 cage.
Yes, one of those is an 8. We either have an 8. Yes, I agree. Okay. Can we do a little more pencil marking just for my own sanity?
Of course.
So 5 is 5 in box 6 is not in this row because of that 5. So 5 is up here. 1 in box 5 has to be in one of these 3.
Oh, you looked at the column 8 earlier.
I did.
Let's look at it again now with the...
Oh, right, because 15 and 21 is 36. We can only sum to 9. That's a 3. And that's a 9. If this were a 5, we'd need a 1 here. That can't be a 5. That's a 5. These now have to sum to 6. They have to be 2, 4. Oh, we're cooking with gas now.
6 and 7.
As I now break completely down. Now, this 15 cage can't have 2, 3, or 4 in it. So it has to have a 1 in it. There's a 1 in here, which means there's a 1 down there. Now, if this is a 1, those would have to be a 2, 3 pair with a 6
well, we can take
there.
1 out of the 11 cage anyway.
Take 1 out of the 11 cage anyway. Would this 11 cage?
Yes.
Oh, right, because it's in the column. Yes, fair enough. This one's looking down. Okay. All right. Now,
Pencil mark 6 and 7 in box 6.
Okay. The only digits left, that's a 6, 7 pair. All right. And so now 7 is down here and right there. So there is a 7 in one of these. Not a surprise. There's also going to be other high digits floating around. All right. All right. If this is a 4, 9, then we get 7 and 3, which would have to go with the 2 there. This 3 would have to go with the 2 there, and that would be a 6. That works.
In row 6.
Row 6.
We have an 8, 9. Where does the other 8, 9 go?
Where does it? It doesn't go there. It must go here.
Which means the 9 cage has a 1 in it.
It does. So now, but that unfortunately is the most. So it's either one. Oh no, actually that's helpful. It's either 1, 2, which makes 3, which would have to go with the 6, or 1, 3, which makes 4, which would have to go with a 5. This cannot be a 4 anymore. That was nice. Okay.
And we can pencil mark 3, 4 in row 6, column 1. Center mark. We're missing 1, 2, 3, 4 for the row. 1 is in row in the 9
1,
cage.
2, 3, 4. Yeah.
And that's 2 is in the box.
Yeah.
That's a 3, 4.
Yes. So, and these are what, 3, 4, 6, right? We have 1, 2, 5, 7, 8, and 9. So these are 3, 4, 6 up here.
1 of 2 and 4 is in either the 21 or the 19 cage in box 5.
Oh. Well, we can't have a 2 in a 21 cage.
Mm-hmm.
We could have it in a 19 cage, though.
Oh, there isn't a 4. Where does...
Wait a second. 2 is in
no,
here.
I was wrong about 2 or 4. What?
Yeah, no. No, you're no, are you? Well, we don't have, no, the 4 is here.
Yeah.
The 4 is here. We're okay. So as long as the 2 is here.
So 1 of 2 and 3 is in either the 21 or the 19 cage.
I'm not following that. I've gotten completely tangled up.
We've got 1, 2, 3 in row 6.
Yes.
And the other 2, 3 must go in row 4.
Yes. So there's either a 2 or a 3 here, along with a 7, and either an 8 or a 9.
Neither can go in the 21 cage.
Oh, yeah. Okay, so the other part of 2, 3
is in row 6.
Is in row 6.
No,
Can't be in the 21. It has to be here. So there is either a 2 or a 3 there, which means we have to have a 9 to go with it, because 2 would have to be 2, 8, 9, and 3 would have to be 3,
Okay.
7, 9.
It's a 7, 8, 9 triple.
Yes.
With a 9 in it.
And now we have a 7 in the 21 cage, which is gonna have to have either a 5 or a 6, neither of which can go here because they're already used up in box 5.
3, 5.
So that's a 5, 6, and then down here we have 7, 8, 9. Okay, making some small degree of progress. Now we have a 5, 6 pair in column 5.
Places a 4 in row 5.
Which places a 4. Very, very helpful. We hope very helpful. Where are the other parts of this 1, 2, 3? In column 5. Can't be in the 21 cage. Can't be in the 13 cage. So we've got a 1, 2, 3 here and a 1, 2, 3 there.
You can mark the 4, 5, 6 of the 7 cage then.
So now we've got our 5, 6 pair. We've got our 1, 2, 3 triple. We've got a 4. These two are 7, 8, 9.
Yep.
So the 7, 8, 9 has to go with
4, 5,
9
6.
plus 4, 8 plus 5, yeah, 4, 5, 6. Okay. And yeah.
The other 1, 2, 3 in column 6.
Column 6. The other 1, 2, 3. So here's one of them. Here's one of them.
The other
Can't
one
go in there.
21, so it
We
must
have
be
to
in
be
there.
in here. But I'm not sure where. Could be in either of
Yes.
those. I'm going to take the 9s out from here now. They're obscuring my view of things, and we've kind of got them scoped. So 9 is actually either in one of these two specifically. Oh! 9 is in one of those two. 9 is in one of those three, which means we have to have a 9 in... Where is not 9 going to go in column 6? 9 can't go there in column 6. 9 can't go there in column 6. 9 is in one of these three, which means that's not a 9.
Yep.
Small potatoes, but I'll take it. It does not mean that the 9 has to be here, however. So we could have a 9 there and the 9 up here. But where do the other two 1, 2, 3s go in box 2? They can't go in the 21 cage. They have to go here. These are both 1, 2, 3s.
Yep.
Okay, so these two cells are at least 4 and at most 9. That does not do a whole lot of restriction.
Well, the final cell in that 11 cage can't be a 2 or a 5.
This is true.
Either.
So we can rule out 1, 2, 8 because this can't be any of those values. If it were a 1, 3, 7, it would be 1 here, 3 there, and 7 here. We are looking at the killer cage calculator right now. If it were a 1, 4, 6, it would be a 1 here, and the other half of the 4, 6 there. And if it were 2, 3, 6, that's much more wide open.
Well, the 2 would have to be in row 3, column 4.
Oh, that's right. So it would have to be a 2 here and then a 3, 6 pair in those. So that's a bit of restriction. It's more than I like to pencil mark, but having thought it through, I say we keep it. All right, we were going great guns. Are we slowed down massively? Or are we just waiting to see the next cool thing?
We're waiting to see the next cool.
Okay, good.
We'll
I'm glad to.
The case.
We'll pretend, yes. This 13 and that 13 are different combinations. Don't know if that helps in any way, shape, or form.
The 10 cage in box 8 does not have a 7, 8, or a 9 in it.
10 cage in box. I was just looking at that. Why?
Because there's a 7, 8, 9 triple in the column.
Oh, which means there is a 7, 8, or 9 over here.
Yeah, and it can't be a 9.
Can't be a 9. So there's either a 7 with a 1, 3 or an 8 with a 1, 2.
Which means there's a 1.
There is a 1 in one of these. So that's not a 1, which means that is a 1. Which means this is not a 1. And that's not a 1. And since this isn't a 1, that's not a 6. So these are 1, 7, 8. 1, 7 would go with a 3, and 1, 8 would go with a 2. So this is not a 4. It's either 2 or 3. So now this could be 1 and it can't be 1 and 2.
Because we have to be 1 less than
one less than that. If it were 1 and 3, this would be a 5. If this were a 3, it would have to go with a 2, making that 6. And those are all still possible. There's nothing we can eliminate from that. We definitely have a 3 in one of these. But I'm not sure that helps us.
No.
Okay. But now this 10 cage does not have a 1. It has to be a 2, 3, 5.
Yep.
So 2, 3, 5 here,
Which
means
looks up.
okay, and also it means there's not a 5 here, so there's not an 8 there. Okay, and there
So
is
the
a
8 is in the
5
11 cage.
there. So this is a 6. This 5 has to be there. It looks up to there. That's a 6. That's a 5. You were saying, yes, so the 8 is in here.
Which goes with the
So
2.
there's not a 7. 1 and 8 is 9. Yeah, that's a 2, which means this
That's
is
a 3
3, and that's a 6, and that's a 2.
And the 10 cage has a 7 in it to go with the 3.
That's a 7, which means this is a 9, and that's a 4.
That was nice.
That was really nice. Okay, now what damage did that do elsewhere? That 9 looks up and takes 9 out from there. This 7 looks up, takes the 7 out of there, which means this has to be a 7 because it's the only place left for a 7 in box 5.
Which looks up to the 7, 8 in box 2.
So that's an 8. And so this is not an 8. This 6 looks up, making that a 5. So now this is 12. 12 to get to 21, we need a 9, which makes this an 8, which looks over and makes that a 9, which looks up and makes that an 8. Woo! That was a big rush. I enjoyed that. These
21.
5s also look up and make this a 4, which has to go with a 3 to make a total of 7, making 3 out of those. Go ahead.
21 cage has to be
21 gauge.
6, 8, and 7.
Yeah, it no longer has a 4 in it, so it has to be, this has to be a 6, 7 to go with that. So that is the 6, 7. This now has to be the 9 because we needed a 9 in the column. This one, 2 looks down. It takes 2 out of those, and the 3 at the same time is looking down and making that a 2. I'm going to get rid of the color here. We've used that up.
Yep.
Okay. Now what?
Now the 9 cage in box 1 has to have a 3 in it.
Tell me why.
Because
because this
the only
3
place in
looks.
the column.
In fact, these 3s come out.
Yeah.
Hang on. 3s. Yeah, and 3s cannot go in there, so there is a 3.
Oh, the 11 cage now is at least 4, 6 in
Oh, yeah.
3, so it's a 1,
It is
6.
actually a 4, 6 then. With a
With a
1. Which makes that a 2. And takes the 1 out from there. Okay. Now, a 9 cage with a 3 in it, it's either 1, 3, 5 or 2, 3, 4. If it's 2, 3, 4, that's a 2, and this is a 3, 4 pair. If it's a 1, 3, 5, this is the 3,
Yeah,
and that's a 1, 5. I don't think we do either. I just wanted to sort of think it through. But we can't have a 3 and a 6 in the same 9 cage, so there is a 6 in the 12 cage. And it's going with either a 2, 4 or a 1, 5. That takes 6, 7 out of the running as a possibility here. 4, 9 is also out of the running, so this is a 5, 8 pair.
We can pencil mark, corner mark 7 in column 3 in box 7.
Corner mark 7 can't go there, 7 can't go there. Excellent. Which places 7 up there in box 1.
Oh, the 13 cage is a 5, 8.
Yeah. I just said that. It was a 5, 8 because the 6 comes out because of the 12
Why
cage.
can't it be the 4, oh,
Because the 4, 9 pointing over.
So, but that resolves the 12 cage, because it now can't be 1, 5, 6. It's 2, 4, 6.
Oh, yeah. Nice. Nice. So, 2, 4, 6. This is neither a 2 nor a 6, so it's a 4. And this 2 looks over, so this is the 6, and that's the 2. So these are now 1, 3, 5. So that's the 3, and this is a 1, 5 pair. Oh, this is just resolving beautifully now. I mean, that's right. I just jinxed this, didn't I? I'm sorry. I'm sorry.
3 maybe.
Oh, or how about row 6 with a 2 looking right? Give us a 4, which looks up to give us a 2, which looks left to give us a 3.
Which needs a 7 in the cage.
3 and 9 makes 12. We need 7 to get to 19. Also, this 3 looks left, which
so
gives us a 4, 6 pair, giving us a 3. All right. Where does 1 go in column 3? can't go in box 1. These are all assigned, so this is now a 1, 7 pair.
Leaving a 9 in the box.
Leaving a 9, yeah. Beautiful. Okay. Row 7 now needs 1, 8, and 5. The 5 looks down. This is either 1 or 8, and this is a 5. So now we have a 21 cage that has a 5, needs a 7, 9. Yep, 7 and 9 to complete it. And these are now 1, 6, and 8 to make the 15. So this one is 6, 8. That's 1, 6, and this is 1, 6, 8. Get rid of my corner marks. Okay. Oh, this 7 looks down, giving us a 6 and a 7. This 7 cage can no longer be 2, 5. So it's either 1, 6 in that order because of the 6 looking over.
3 in a particular order.
Or it is 3, 4 with the 4 looking over and telling us it would have to be 3 there and 4 there. I took the 1 pencil mark out from this cell because we can't have a 6 there. The 7 looks left. We get 1 and 7. I'm looking for other things that we've missed in the world of Sudoku. I'm sure there are some. So row 9 still needs 3, 5, 6, and 8. That's
6 go in the row?
Well, that was going to be my question. So these, this cell cannot be 6 or 8 because of the column. So this is either 3 or 5, giving us a 3, 5 pair, which gives us the 6, gives us the 8, and then the cages give us a 5 to go with 8 to make 13, and a 1 to go with 6 to make 7. That 1 looks up and gives us the 8, the 1, 8.
There's a 5 in box 9 already.
There's a 5 in box 9 already. Excellent. There's also now a 5 in box 8. So either way, we get that, and we're left with a 4 to complete row 8 and box 9.
Column 7, maybe?
Absolutely. 5 and 9 are left to place.
Yeah.
And in
column 2, 3, maybe?
Okay, in column 3. We've got 1, 2,
8 and 9 to go.
1, 2, 3, yeah, 4, yeah. 8 and 9, and they're placeable because of this 8.
Which is going to resolve the 5s, 9s,
9
and 1
8.
5s.
Yep, this 9 looks over. That gives us a 5 with a 9.
5 looks over.
5 looks back this way, giving us the 1 and the 5. The 1 looks over and gives us the 6, which gives us the 8 and the 1. The 6 looks left and gives us the 7 and the 6. Oh, this is really beautiful. We might actually finish. I was not convinced that we were going to. Row 1 needs a 7, and there's already a 7 in box 3. So this is the 7, and then we need a 2 to complete the row. Row 2 needs a 3 and a 4. There's a 3 in the box, so that's a 4, and this is a 3. Box 3 needs a 4. This 4 resolves the 6, 4 pair, and now this box needs a 2. And the 4 also looks down, and you ready?
Yep.
You ready? That is the correct solution. 41 minutes, 51 seconds. It took us a while to see. I think really the key that we should have seen sooner was that question of where does 5 go in this row? Because we had that from really early. We knew these had to total 10, so we couldn't put a 5 in that box. This 7 kept the 5 from being in the 12 cage. I think that if we had seen the 5 in that 15 cage earlier, this would have been a much shorter solve. But that's okay. I enjoyed it. Yeah, it was really, really nice logic. But our apologies to Sotek for not seeing that sooner. And
but what a lovely puzzle.
What a lovely puzzle. Really stunning cage interactions. Really nice restrictions on which digits went where.
It didn't just fall apart when we found the 5.
No, it didn't. And part of what did sort of fall in place already, we would still have had to sort through with where are low digits going, where are 8s and 9s going in box 8, where are the high digits going, how are we going to make the 19 cages and 21 cages.
Hopefully if the video sees the light of day, Sotek can tell us what we missed.
Yes, besides the 5 and the 15 cage. But yeah, so no, beautiful, beautiful puzzle. Thank you so much for setting it, Sotek. Thanks you for sending it. Yeah, for giving us a chance to do a guest solve. And as Brem says, good luck with your solving.